Today we're going to look at solving a couple more radical equations. So you can just continue these on from your notes from yesterday's video. So yesterday we did 3 examples. Here we're going to do example 4 and 5. So example 4, if we're given x plus 1 equals the square root of 7x plus 15. Again, the first thing we want to do is make sure our radical is isolated. So if you notice here, we have the square root of 7x plus 15. There's nothing else on this side with my square root, so it's isolated, and we can go ahead and raise both sides to the same power. So in order to get rid of the square root, we're going to square both sides. If you notice, when we square both sides, we end up with 7x plus 15. Over here, we have x plus 1 squared. You cannot distribute that squared because there's a plus inside. So you do not distribute that squared when there's a plus or a minus inside. So that's the same thing. X plus 1 squared is x plus 1 times x plus 1. So we're going to have to FOIL this. Okay, we're going to distribute it out. So we end up with x squared plus x plus another x, so plus 2x. I just added the insides together, and then 1 times 1 is 1. That equals 7x plus 15. We need to set this equal to 0 so we can factor, so we're going to subtract 7x, subtract 7x, subtract 15, subtract 15. That'll give us x squared minus 5x minus 14 is equal to 0. So now we want to factor, look to see what multiplies to get negative 14 and adds to be negative 5. That would be negative 7 and positive 2. So it'll factor to x minus 7 and x plus 2. So my solutions would be x is equal to positive 7 and x is equal to negative 2. Now again, we said you always have to check your answers for extraneous solutions. So if we plug 7 in, remember our original equation is x plus 1 equals the square root of 7x plus 15. If I plug in a 7, I get 7 plus 1 equals 7 times 7, which is 49 plus 15. So hang on just a second, which is the square root of 64 equals 8, which that checks out, so the first one is good. If we plug in negative 2, so we'll have negative 2 plus 1 equals the square root of 7 times negative 2, which is negative 14, plus 15. That would be the square root of 1 equals negative 1. The square root of 1 is 1, not negative 1. So when we do this, since we get the square root of 1 to be 1 and not negative 1, this doesn't work. So this would be, this would be an extraneous solution. So x equals 7 would be our only solution. We're not going to use this one because it's extraneous. It comes out to be an incorrect statement. So let's do one more example here. So the last example we're going to look at is example 5. This is the square root of x minus 6 equals x minus 8. So again, we already have that square root isolated. It's there by itself. So to get rid of that square root, we're going to square both sides. When we square both sides, we end up with x minus 6 is equal to x minus 8 times x minus 8. So we want to FOIL it out. If you need to show all the steps and process in between, then go for it. So we've got x times x, which is x squared. Then we've got x times negative 8, which is negative 8x. I'm going to just write it out over here. And then we have negative 8 times x, which is another negative 8x. So those together would give me negative 16x. And then negative 8 times negative 8 would be positive 64. We need to set this equal to 0, so we're going to subtract x from both sides. And then since this is a minus 6, we're going to add 6 to both sides. So we'll end up with 0 equals x squared minus 17x plus 70, which then we want to factor. So we've got x minus 10 times x minus 7. Our solutions then would be x equals 10 and x equals 7. So we can plug these in and check to see if they work. So if we plug in 10, again my original was the square root of x minus 6 equals x minus 8. So if we plug in 10, we get the square root of 10 minus 6, which is 4, equals 10 minus 8. The square root of 4 is 2. 10 minus 8 is 2, so my first one checks out. So then if we try 7, we end up with 7 minus 6 equals x minus 8. 7 minus 8. So 7 minus 6 is 1. The square root of 1 is 1. 7 minus 8 is negative 1, so we get 1 equals negative 1, which is not true. So this is extraneous, and x equals 10 is my solution. Another way you can do this is you can graph it in your calculator. So this is your alternate check. If you go into y1, you're going to type in the square root of x minus 6. In y2, you'll type in x minus 8. So if you go to your graph, you're going to look for that intersection. So if you look at x minus 6, it's going to look similar to this. X minus 8 is going to be a line that looks like this. So if you look at the only point where they intersect is going to be right here when x is 10. Over here when x is 7, they're not intersecting. It would still be below the graph. So you can also look in your calculator where the left side of your equation equals the right side of your equation and find that intersection point. Now, you have to show me all of this algebra along the way. You will not receive credit if you don't show me all the algebra along the way. This is a way to check your answer and find that extraneous solution.